Welcome to Konnur online classes. Then we can take another problem. If a plus b plus c is equal to 180 degree. Sum of these three angles a, b, c. Suppose a plus b plus c is equal to 180 degree. The given value tan of a value is 1, tan of b value is 2. Then show that tan c value is 3. First, given that a plus b plus c is equal to 180 degree and tan of a value is 1, tan of b value is 2, then show that the value of tan c is equal to 3. Then solution for this problem is here given a plus b plus c is equal to 180 degree. A plus b plus c is equal to 180 degree. 180 degree. Then here a plus b is equal to 180 degree minus c. Here plus c is shifted to RHS side. We get minus c. Then here applying tan value. Tan of a plus b is equal to tan of 180 degree minus c. We know that 180 degree minus theta belongs to second quadrant. That's why tan of a plus b is equal to tan of 180 minus theta. Since it is the second quadrant, sine the reciprocal cosecants are positive, tan Western should be negative. That implies tan c value, because tan of 180 degree minus theta is equal to minus tan theta. Suppose it is a sine of 180 minus theta, its value is plus sine theta. Cosec of 180 minus theta, its value is cosec theta. In case of sine cosec, remaining all values are tan of 180 minus theta is minus tan theta, cos of 180 minus theta is minus cos theta, because second quadrant sine and the reciprocal values are positive, remaining all are negative. That's why we can take tan of 180 minus theta value is minus tan c value. Then we know that the formula tan of a plus b. Here tan of a plus b value is tan a plus tan b divided by 1 minus tan a into tan b is equal to minus tan c value. Then we can substitute tan a value as well as tan b value. This is the formula for tan of a plus b. We know that tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Here applying substitute the value of tan a is 1 plus tan b is 2 divided by 1 minus tan a value is 1 into tan b value is 2 is equal to minus tan c. Then 1 plus 2 is 3 divided by 1 minus 2 is equal to minus tan c. Here 1 minus 2 is minus 1, therefore minus 3 is equal to minus tan c. Here minus minus cancelling both sides, we get tan of c is equal to 3. Tan of c is equal to 3. We can show that tan c value is 3 belonging to tan a value is 1, tan b value is 2. Then show that by using the concept of a plus b plus c is equal to 180 degree. Then by using this concept, we show that tan c value is 3. Then given that a plus b plus c is equal to 180 degree, then shifted to c RHS side, then applying the taking the tan on both sides, Then we applying the tan of a plus b form, we get the result here. Then applying tan a value and tan b value, we get tan c is equal to plus 3. We get the result. A simple problem, another one. Prove that tan of 2a, tan of 3a into tan of 5a value is equal to tan of 5a minus tan of 3a minus tan of 2a. First we consider highest value, tan of 5a. Tan of 5a, we can consider tan of 5a. Then tan of 5a value is split as tan of 2a plus 3a. This type of problem we can choose highest term. Highest term, here tan of 5a is the highest term. Then tan of 5a value is taken, then splitted 5a into 2a plus 3a. Here tan of 5a is equal to, we know that the formula tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Applying here tan of 2a plus tan of 3a divided by 1 minus tan 2a into tan of 3a. Here tan of 2a plus 3a written as, we know that the tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. In place of a, 2a is there. In place of b, 3a is there. Applying this form into this side. Here shifted this one to this side. Tan of 5a into 1 minus tan of 2a into tan of 3a is equal to tan of 2a plus tan of 3a. Here then tan of 5a is there. Here 1 minus tan 2a into 3a shifted to this side. Here multiplying tan of 5a in this bracket, tan of 5a minus then tan of 5a into tan of 2a into tan of 3a is equal to tan of 2a plus tan of 3a. Tan of 3a. Then here shifted this term in RHS side. That is tan of 5a here. Then tan of 2a is shifted to this side. Minus tan of 2a here minus tan of 3a. Minus term is goes to RHS side. It's a plus tan of 5a into tan of 2a into tan of 3a. Tan of 3. Here tan of 5a as it is. Then tan of 2a taken this side, LHS side. Here it is a positive, comes under LHS, it's a negative. Here tan of 3a, here positive, here come to negative. Then it's a product 1. Total is a product 1. Minus term goes to RHS, then it's a definitely plus. Here 5a into 2a into 3a shifted to RHS, then its value is positive. Then this is the final result taking to this side. Here tan of 2a, tan of 3a, tan of 5a. This result is there. Here this side taken as first one tan of 2a, tan of 2a, then into tan of 3a into tan of 5a. RHS is written in a LHS side. Then is equal to tan of 5a. Here tan of 5a minus tan of 3a shifted to this side. Tan of 3a minus tan of 2a. Here, this is our final result. Final result. Here, to prove this one, LHS is equal to RHS, we can take tan of 5a, highest term belongs to this one. Here, tan of 5a split into 2a plus 3a. Then tan of 5a as it is. Then by applying, we know that the tan of a plus b, tan a plus tan b divided by 1 minus tan a into tan b. In place of a, here 2a is there. In place of b, here 3a is there. Then we shifted to this side. Then 1 minus 2a into 3a shifted to tan of 5a side. Then here this result is. Then multiplying tan of 5a value, then applying the simplification, we get the result. Here, if tan of a is equal to 5 by 6 and tan of b value is 1 divided by 11, then show that a plus b value is pi by 4, that is 45 degree. Here, tan of a value is given, tan of b value is given, then we can show that a plus b is equal to 45 degree or 5 by 4. Then we can consider tan of a plus b, tan of a plus b. We know that the result tan of a plus b value, that is tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b value. Here, that's tan of a plus b value is considered. Then applying the formula is tan a plus tan b divided by 1 minus tan a into tan b. Because we know that the value tan a, tan b and tan a, tan b value. That's why we can consider tan of a plus b. Tan of a plus b, because tan of a minus b is also considered, but we can get the result a plus b. That's why we can take tan of a plus b form. Then here tan of a plus b, tan of a plus b is equal to, we know that the result 5 by 6 plus tan b value 1 divided by 11 whole divided by 1 minus tan a value 5 by 6 into 1 divided by 11. 1 divided by 11. That's tan of a plus b is equal to, here multiply 55 plus 6 divided by 66 whole divided by, here 66 minus 5 divided by 66. Then tan of a plus b, tan of a plus b is equal to, here 55 plus 6, 61 divided by 66 whole divided by 66 minus 5, 61 divided by 66. Here 61 divided by 66 as well as 61 divided by 66 is cancelled. Then tan of a plus b value is 1. Then tan of a plus b is equal to 1. 1 can be written in terms of tan of a plus b is equal to tan of pi by 4. Tan 45 degree value is 1. That's why we can take in place of 1 tan of pi by 4. Remove the tan term, we get a plus b is equal to pi by 4. Here our final result. Then here tan of a is equal to 5 by 6, tan of b is equal to 1 divided by 11. Then show that a plus b is equal to pi by 4. Here consider tan of a plus b value as a formula. Then applying tan a value and tan b value, we get tan of a plus b is equal to 1. 1 can be written as tan of pi by 4. Removing the tan term, we get a plus b is equal to pi by 4. If sin a value is 5 divided by 13, cos b value is minus 4 divided by 5. Here, angle A is belonging to a second quadrant. Angle A belongs to second quadrant. Angle B belongs to third quadrant. Because pi B value is in between 5 and 270 value. Then, by using these concepts, show that find the value of sin A plus B value, cos A plus B value, tan of A plus B value. Consider given value is, take given value directly. Given values are given sin A is equal to 5 divided by 13. 5 divided by 13. Then we construct one right angle triangle. That is an angle A. Here define sine opposite divided by hypotenuse. Definitely this value is stopped because Pythagoras triplets. Here A value is belongs to second quadrant because 90 and 1 A value is in between 90 and 180. That's why A is belongs to second quadrant. Then sin A value is given. Then we from this right angle triangle we can take cos A value. Cos A is equal to 12 divided by 13. 12 divided by 13. Cos is negative in second quadrant. That's why its value is negative. Then again cos B is given. Cos B is equal to minus 4 divided by 5. Again construct one right angle triangle. That's a B. Define 4 divided by 5. Adjacent divided by hypotenuse. Definitely its value is 3. Then cos B value is known. Then sin B. Sin B is equal to 3 divided by 5. In third quadrant, tan the reciprocal cot or positive. Definitely sin value is negative. By using sin A, sin B and cos A, cos B, then we determine the value of sin A plus B. We know that the formula sin of A plus B is equal to sin A cos B plus cos A sin B. This is the formula for sin of A plus B. That implies sin A value is 5 by 13 into cos B value minus 4 divided by 5 plus cos A value is minus 12 divided by 13 into sin B value is minus 3 divided by 5. Then 5 into 4, 20. That value is minus 20 divided by 65 plus here minus of minus plus 36 divided by 65. 36 divided by 65. That implies here plus 36 base is same plus 36 minus 20. Its value is sin of A plus B is equal to minus 20 plus 36. Value is 16 divided by 65. 16 divided by 65. Again, we solve the problem cos of A plus B. Cos of A plus B. We know that the formula cos of A plus B is cos A cos B minus sin A sin B. Sin A sin B. Then substitute the value. Here sin A value, cos A value is minus 12 divided by 13 into cos B value minus 4 divided by 5 minus sin A value 5 divided by 13 into sin B value minus 3 divided by 5. Here cos of A plus B is equal to here minus of minus plus 48 divided by 65 minus of minus plus 15 divided by 65 15 divided by 65. Then cos of A plus B is equal to 63 divided by 65. 63 divided by 65. This is the cos of A plus B value. Cos of A plus B value. Then by using sine of A plus B and cos of A plus B, directly we get the result tan of A plus B. Tan of A plus B. Tan of A plus B is equal to sine of A plus B divided by cos of A plus B. Cos of A plus B. Then we know that the result sine of A plus B is recording result is tan of A plus B is equal to sine of A plus B value is 16 divided by 65 whole divided by cos of A plus B value is 63 divided by 65 65 get cancelled. Then tan of A plus B is equal to 16 divided by 63. By using the same concept, we solve sine of A minus B, cos of A minus B and tan of A minus B. Here sine of A minus B, sine A cos B minus cos A sine B. In place of plus we add minus, we get sine of A minus B. Here cos of A minus B is cos A cos B plus sine A sine B. Then by using sine of A minus B and cos of A minus B, directly add tan of A minus B is equal to sine A minus B cos of A minus B. Directly we get the result. Very simple problem. Here tan of 45 degree plus A, tan of 45 degree plus A into tan of 45 degree minus A, value is 1. To prove that tan of 45 degree plus A into tan of 45 degree minus A value is 1. Consider LHS part. LHS. Tan of 45 degree plus A into tan of 45 minus A value. We know that the formula tan of A plus B, that is tan A in place of A 45 degree is there, 45 degree plus tan A divided by 1 minus tan A into tan B. B value is A into tan of A minus B form, that is tan A means 45 degree minus tan B value is A, that is 1 plus tan 45 degree into tan A value. Then tan 45 degree value is 1 plus tan A whole divided by 1 minus tan 45 degree is 1 into tan A value is tan A into tan 45 degree is 1 minus tan A divided by 1 plus tan 45 degree is 1, then tan A. Here this is our required result. Here 1 plus tan A, 1 plus tan A get cancelled. 1 minus tan A, 1 minus tan A get cancelled. That implies this is the 1 RHS. First we can take LHS tan 45 degree plus A into tan of A minus B form. We know that the result, that is tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A into tan B. Similarly, tan of A minus B is equal to tan A minus tan B divided by 1 plus tan A into tan B. Here in place of A 45 degree is there, in place of B A is there. Then applying this result we get LHS is equal to RHS.